Hey everyone, welcome back to my YouTube channel. So, if you are passionate about the cybersecurity, ethical hacking, or building a secure web application, you are in the right place. In today's video, we are diving into OWASP top 10. That's the most critical web application security risk identified by the Open Web Application Security Project. So these are the real threats that affect the millions of websites every year, from SQL injection to broken access control and beyond. Whether you are a developer, bug bounty hunter, or any cybersecurity enthusiast, understanding these risks is a must. I will walk through each of the top 10, how to identify them, and most importantly, how to mitigate them. So let's jump right in. So let's learn about the OWASP top 10 application security risk. So at the first we can know what is OWASP. So OWASP means like Open Web Application Security Project. It is a non-profit organization which trying to improve the software security. So it has been published a top 10 industry standard web application risk which help the developers and organization to build a secure software. So as I mentioned, OWASP stands for the Open Web Application Security Project. So it's a non-profit web application security project. So those of the 1,000 cybersecurity experts, developers, and ethical hackers from around the world are all working together to make the software more secure. So there are the top famous project in the OWASP which is listed that the top most critical web application security risk. So this list of update every few years based on the data from the real world vulnerabilities and collected from the security firm, bug bounties, programs and open source project. And it's not just a theory, it's the OWASP top 10 is used by the major companies, government agency and even thought the university as to go to standard for the web application security. So let's firstly start with the top 10, that is one that is broken access control. So here we can start, see, like let's go to the first and the most dangerous one of the list, that is broken access control. So it's occur when the user can act outside the intended permission. So we can just say with an example, so that will be better. So now think about the access control, what determine what the can do, like for example in on his website. For that an example, an admin can delete user, but a normal user couldn't able to do right that. So when that control is broken, well, that's a thing go horribly wrong. So so that's what I have been mentioned here. So that means, like let me give an example another, that imagine you have logged into a regular user and you go to the URL, so like the user or edit /1. So and suddenly you realize that if you change that 1 to 2, you can access someone else's account. So that's a common we can able to do. So that's a classic example of the insecure direct object reference, one type of the broken access control. So how to we can refer, like attacker can abuse this escalator privilege and access the private data or perform the actions they are not supposed to, and most of the time the application won't even note it's happening. So how to prevent, like how to find it. So this is something we often test during the bug bounty using the tools like Burp where we capture the request, modify the parameters like the user IDs or the token, and see if the app let us the bypass those restrictions. Manual testing work great here, especially if you try to access admin only APIs or the URL using the low privilege account. So as mentioned the Burp suite. So the tools we have been used is the Burp suite to manipulate that, and how to mitigate or how to fix it. So well, fixing this comes down with enforcing the access control on the server side. That means that do not trust anything from the front end. Always check who is the user, who user is, and what they allowed to do on the backend. Use role-based access control. Implement the least privilege and always deny the default unless and user have the explicit permission. And most importantly, test for regularly even if you have a secure access rules. One update can break it. So that's what about the access broken control. So now let's look what is about the top second. So that's called cryptographic failure. So we call it as a sensitive data exposure. So the next about the cyber security on the field of this most, that is cryptographic failure. And sorry for the interruption. So which is used to, so we have been used for this sensitive data exploit. Now this is, it's not about the password, it's about the sensitive data like the credit card numbers, personal information, and even the tokens using and leaked because the encryption was not properly implemented. So let's say that the user into the website but their password is stored in a plain text in the database, or maybe it's a site uses a HTTPS instead of HTTP instead of HTTPS. So this means like annoying shifting and at the network. So like on a public Wi-Fi could interrupt and read the data. How do we spot this? So let's talk about how we can spot this thing. So it's like that, use tool like a Burp suite and the Wireshark to inspect the traffic. And are the password of the token being sending in a plain text, or are the cookies missing in the secure or the HTTP only flag? So these are the red flag. So to fix this, always use the TLS 1.2 or above that, and that HTTPS. Never store the sensitive data without encryption. Use the proven cryptographic libraries and never roll your own crypto, and make sure that you have backup of the log to protect them too. So these are the things we have to look while the cryptography failure. That means like we have to prevent, we have to make a secure encryption for everything, strong password, use HTTPS, and we can completely say, for example, HTTPS we became using, it's 100% of secure, but still it's a secure one when it's compared to HTTP. But also, as we mentioned, that the cryptography failure not even happen through the HTTPS. So it's also happened the algorithm like AES algorithm. We have to use the updated version. We have to use the currently updated version like TLS 1.2 and most things, like we have to use the more things that is happening today without using the old version. So that will secure ours from this, that will help us from this cryptography failure. So now let's talk about the injection. So that's one is a classic. So injection attack. So that's most famous in the SQL injection. So that's like it happened when the user input is sent directly into the backend interpreter like a database or a shell without the proper sanitization. So imagine a log from when someone types that zero, like what will they say, the 0 1 equal to 1 and into the username field. If the backend directly plug that within the SQL query, the attacker bypass the authentication and log in as an admin. So that's how now dangerous it is. And with this rest of their insert in the payload in the input field, and headers, cookies, and watching how the app respond. The tool like SQLMap can automate this. To prevent it, we can use simply a prepared and unprepared statement like store procedure and ORM framework, and that automatically escape the input. So even from the trusted sources also. That's what about the injection. Now we can look the fourth one, that is insecure design. So insecure design is one of the newer entries on the list. It's not just about the bugs, it's about the bad planning. So it's, if your app doesn't consider security from the design phase, you're setting yourself up a failure. So for example, let's say your site has a no rate limit on a login attempt. That shows that the brute force attack or maybe your user flows did not prevent IDOR issues. So these are the design flaws, not a coding mistake. So to detect them, you need to thread the modeling and design the reviews. Ask yourself what could be wrong at every stages of the system. To fix this, we have to shift the security left and involve in the security expert during the architecture and planning. So use secure design pattern, do threat modeling, and adopt the framework like a STRED or OWASP. So this will help you to mitigate these all problems. So I'll apply the secure design principle, so it will help us to security in the all ways. So now let's talk about the security misconfiguration. So it's about a big one. This is a big one, which means like a super common attack. Security misconfiguration means like it's a thing like we leaving a default credentials and enabling the unnecessary services. like having an overall verbose error messages or not setting the security headers. For example, we can see like a web server still running in the admin interface or an S3 bucket that's public to everyone. To find this, use automated scanners like Nikto and Map and USSS. So, and also you will definitely uncover the open port and outdated software and the debugs. To fix this, we have hardened everything. So disable and what you do not use and set a proper permission. Use secure headers like a content security policy, X-frames, and always keep the software updated. So this is what about the fifth one. And now let's look what is the sixth, that is vulnerable outdated components. So it's simply if you are using a third party libraries or any framework and you don't update it and you are at the risk. So that's what about this. So the Log4 shell in the 2021 was a great example for the millions of app broken because they have been used vulnerable version of the Log4j. And so even if your code is clean and your dependency could be ticking time bombs. So how to detect this all the things? So we have to use the OWASP Dependency-Check and sync and even GitHub security alert. And how to find and how to mitigate. So that's the target of the components, like use the software build and of the bill of material, that is SBOM, avoid abandoned libraries and always the monitor CVE database. So that's how we can find out the outdated components. Now let's look about the seventh, that is identification and authentication failure. So this is one about the broken login system. So this like a weak password, no multi-factor authentication section and IDs, and that is doesn't expire or predictable tokens. So these are the lead to identification and authentication failure. So even seen a site where you can reuse the same section forever, or where there is no account logout after failed login, and that's a red flag. So you have to be careful. So to test this, try a brute force attack, forcing or token prediction or a section fix section. So tools like a Hydra or Burp interpreter help a lot. And how to mitigate? So enforce the strong policies, implement MFA, that is multi-factor authentication, send a short section timeout and generate a section ID after login. Use a secure cookies, so it will help us to mitigate from this type of attack. Now the eighth one, that is software data integrity failure. So this one is about the trusting unverified source. So if your app updated itself or the load the plugin from the sources that is not a validator, you are in the trouble. So like a CI/CD pipelines are often targeted. So attacker inject the code in the unsigned update or the tamper with deployment script. And the detection. How to detect we can. So check if you build a process, verify the signature, review a pipeline security. And how to mitigate or fix this, we have to by using the signing update, like using the checksum validation and secure the CI/CD rules, tools, and the tools like a Nikto and Sixstore and the 5 framework like SLSA help us lock this down. So this is what we can do when the software and the data integrity failure. Now let's talk about the ninth, that is security logging and monitoring failure. So even if your app get hacked, so you really should know it. So many of you don't know because there is no login or a monitoring. So this means like incidents are unnoticed, like a no alert of this or for weeks or a month. So how to find out this issue? So let's look that. So stimulate an attack like a multiple fail login and see if it triggers any alert. And how to find it? So it's by fixing the implementing a proper lock with no sensitivity data, setting up alert and having an incident response plan. Centralize the login system like ELK or a SIM like a Wazoo or a Splunk or can be a game changer. Now let's move to the last, that is server side request progress. So that's about SSRF. So this happens when attacker make the server send request on their behalf. And Why this is scary? Because if your servers can be accessing the internal resources like metadata APIs, AWS or internal admin panel, the attacker can too. So how we can detect or find? So it's like trying a URL in the input field and can make a server fetch internal IPs or URLs. So that's and how to mitigate. So we can block the request to the internal IP ranges. We can use the allow listed, sanitize the user input, and use the library that prevent SSRF. So that's all about the top 10. Was the wrap up of our journey today. So that's about the OWASP top 10. I hope this helped you to understand the core vulnerabilities that every web app developer and a security professional must know. Remember, security is not just a one-time effort. It's a mindset. Always test, monitor and improve your code. If you found this video very helpful, do not forget to give it a thumbs up, subscribe for more advanced cybersecurity content, tutorials and other tips. So, if you got some questions, drop them in the comment. I reply to every single one, or let me know which OWASP risk you would like to deep dive in next. Stay curious and stay secure, and I will see you in the next one. Bye.